Yeah, we can start. So first is that like remove the duplicate letters. So a string is given which contains only the lowercase letters. We have to remove the duplicate letters so that every letter appears one and only once. And we must make sure that our result is smallest in lexicographical order among all the possible results. So for this here, both the B and C are removed and it's a sorted one, ABC. Same goes for this ACDB. Yeah. So how do we proceed here?
One, I think, intuitive way would be, so we need to remove duplicates and we want the sorted order at the end, right? So one,
Yeah.
No, not sorted.
lexicographical.
If you see example 2, it's not like.
It's smallest among lexicograph. I mean, there will be many such sorted strings out of. I mean, such strings out of that smallest one we have to take, which is sorted, right?
Right. Yeah.
Oh, I see. So it should be in the same relative position in the original string. Is that what?
Yeah, that's right.
Okay.
Yeah.
Okay.
Maybe it's like a subsequence. Yeah.
Right.
Kind of.
Yeah.
Yeah. Okay. That kind of changes things because I can't lose that sequence.
Yeah. So what the brute force way would be, to start with because we will have to find what are the unique letters in the string, right? That is the first thing we'll have to do. And then we'll have to start from this input string, starting from the first position, and look for each and every, like if we take this BACB, okay, and if we form all of the combinations, something like that, right? So for this BC, ABC, we can say like we have the first one, which is BCA, okay, and then we can go, the second will be something like
CAB.
BAC, right? So we just skip the C in that. And then we move to the C, we have CAB, right? And I think we can't form anything from there. And then we go for ABC, right?
Yeah.
And out of this, which is the lexicographically the smallest one, I think this is the one, right?
Last one.
Yeah. So forming this, maybe we'll have to take help of some data structure like a set or so, or.
But order will be what do you say? Lost in case of set, right?
No, at least to find out, when actually I'm traversing this string and I want to know if I've used all the set, all the unique ones only, right? So I can use the annotated set in that case.
Okay.
So whenever I actually go through this one, start from this position, okay, I can put that in the set. So I go to the next one, I can put this in the set. When I put this, then I can, it is clear that I have exhausted all of the unique ones, right? Because then I can't go ahead. So similarly, do for like, I can start from the position C and then B, and then I can't do anything from B and C, these ones, right? Because they are lesser than the number of unique letters.
Yeah.
Yeah.
Essentially, we are saying we are first constructing this, like, for example, four element set, so to speak, and you're using some set or hash map to check the duplicates. Is that right?
Yeah,
And then
maybe
later,
that can be
we'll
done.
have logic to figure out the best one.
Also, if we just construct this as a string, and then when we're in a loop, if we go for the next string, if we just compare both these strings, we can come to know which is the smallest one, right?
Yeah.
And we can just eliminate the one which is not bigger one.
Correct.
Yeah, and then keep on doing. So at the end, we'll have a single result.
Yeah, smallest one.
Yeah, but that will be a brute force, a sort of optimized brute force or whatever, because we are using a data structure, correct?
Yeah. Because of that set, yes. So you're generating all the possible substrings of unique characters.
Right, right.
Yeah.
And so what is a better way of doing it?
Stack, if we use, we can like you
Mm-hmm.
keep on pushing the characters, right? I mean,
Okay.
monotonic stack, I was saying. So,
Okay.
like, I mean, let's say this is there. So we'll see first, we'll insert B. And next, if we see C, C is in a, I mean, it's in a proper way, right? After B, lexicographically C should come, right?
Mm-hmm.
And now when you try to insert A, so both these two are bigger than A. So we'll pop this, I mean, we'll keep on popping the stack and insert A. And then again, B you can insert because ASCII value is of B is greater than A. And then C you can insert. By that time, string will be over. So we'll get
Why don't
this
simply
ABC, right?
you can only remove C when you have another occurrence of C later on in the string.
Yeah, we'll keep track of last position. Yeah, we can take the next example, this one, second one.
Okay.
So
Yeah.
what we can do, so initially let's say C we took. We now B is allowed also in a decreasing order. I'm taking it here. Then if I take, then I'll have to pop both of them and A will be inserted. Then
Let's say we just have
I,
CB.
no, sorry,
yeah.
I made a mistake. Yeah. So if I insert first, I'll insert C, right?
Okay.
Then if I insert, I can't insert B. I'll have to pop it
No, why
and
not?
then insert B. Now uh, because I mean I was doing it in a what do you say, ASCII value of B will be less than C.
No, so let's
But
take a smaller example first. Let the example be CBA.
Yeah, I think he's trying to maintain a monotonic increasing stack, correct?
yeah.
So in that case, that is right. When you push in C first and then you come to B, you'll have to pop out C, correct?
C, yeah.
Yeah, but
Because
you cannot just pop it up like someone say. Take an
What?
example of CPA. You know, if you pop it up, then at the end you only have A,
B.
which is
Okay.
incorrect.
So what we
Because
can
every
do,
time you see that you pop it up, and then
Okay,
at the end
let's
you only
first
see A, right?
count
yeah,
really
if
simple.
you have more number of C's, you cannot pop it up, you know. So yeah, you cannot use directly the monotonic increasing stack. You will have to use a modified version of it, correct?
Yeah.
So you'll have to even look for the frequency counts of each and every letter.
Right.
I think
What
what
if we
Leon is
have,
saying,
yes,
so
so
what
two
if we
data structures.
have,
right? Uh-huh.
so what if
The
we
one
have
set
something like,
dictionary I'll have to maintain, which will keep track of which character is occurring at which index.
Then when you know when you're gonna stop. I mean, you're not gonna stop to the end, right? Because you have that.
Okay.
Could you
Before
explain with
going
that
with that,
extra
I
data
think,
structure?
before going with the monotonic stack one, we can go for the other, in the solution they have described another approach, right? So if we actually go through that, the things might be slightly better off. Can we
Hey,
go to
Santosh.
that solution first? I think
Hey,
DP has a question, right? Just a
Okay,
minute,
yeah.
yeah. Yeah, DP, what was the question?
my question is, if I take a string like CD, simple one, so
Uh-huh.
my stack will accept that. And then when I
No,
read, let's say that's my input string, right? Now answer should be CD only, right? Because that's
Yeah, that is the only subsequence you have. So
right.
it has to be CD, correct.
Right. So when I push it into the stack, so it just goes straight like C and then D. And then when I pop it from the stack, I get D and DC. Isn't that?
Yeah, so when you're swapping out, you'll have to actually insert it in the reverse order. Yeah, that is right. Yeah. So, but you'll have to take
Hi.
help of a stack if you have to get a very efficient implementation in this.
So one other question. Uh, I sometimes tend to struggle about coming up with an idea like this. Like I wasn't able to jump from the brute force to this monotonic stack. You know,
Mhm.
like if I know it, I'll do it. I mean, next time it's something I know, so that's awesome. But like, do you guys have intuition behind like that? How do we kind of think through this? Like, I wouldn't have suddenly thought of this solution.
Yeah, that's correct. Actually, most of these people have been working on similar problems, as
Okay.
well as they are reading through the discussions,
Yeah.
and trying to discuss most of the stuff what they have read through.
Right.
Because some of the things are very hard to come up, and this is a
Yeah.
hard question. So we have
Yeah.
to take support of all the discussions. That is for sure. Yeah. So
Right.
I was saying, in the solution we have another approach. So let us go through that first,
Yeah.
right?
Hey, Santosh.
Yeah, Biju, yeah, go ahead.
Sorry I joined late. The quick question on this is, uh, why can't we just take the, I mean, I'm just thinking loud, why can't we just take the, count of all these distinct letters? In one pass, we can take the count, and then in the second pass, we can just, or not even the count, we just maintain a hash set of all these characters, and then, print them in sorted order.
We actually, that is a good one to do, but in this case, we'll still have to maintain the what you say order.
Yeah, ordering of given
Order is
string.
important because it is like a subsequence. Okay. Yeah. So I think
order of the sequence is important.
Yeah.
Yeah. Like the second example, if you see, I did the same.
Yeah. So So what you said is right. We'll have to keep a frequency count. Okay. So that is important. So okay, Shashank is back again.
Yeah, I got disconnected.
No problem. So okay, if you go through the solution, they have that one way of doing it. What they are saying, So if we take the example of CBAC, DCBC, right? So first we need to find a frequency count. Okay. So the frequency count, if I find, like, I can use something like an array also of 26 characters, because initially we never cleared on the requirements, because there is nothing about like the letters are going to be lowercase, right? Are they? Oh, they say that. That is clearly mentioned, so it's okay. So we can have a frequency array of 26 locations, and then we can have all these, like first in this case we have C, we have 3 C's, and then we have 2 B's, right? And then we have single D and single A, right? And then what they are saying, now you start from this position, okay? And so whenever you are starting from this position, you need to look for the next one, okay, for the next character letter. Try to see if this character is greater than this one. Okay, so if this character is greater than this one, actually you need to actually move your position from this position to here. So keep on doing that. So when we come here, our position will be A here, because this will be the least position. Okay, so
sorry, you're comparing C with which character again?
So okay, so what I will do is I'll keep an position. Initial position will be 0, and then I will start iterating from the main string. Okay, from the again Shashank went off. Okay. So let me share this one. I'll just go on the whiteboard. I think he is having a bad time there.
Yeah, then you won't be able to annotate.
Yeah, I can share, but again disconnected.
Okay, no problem. I think you
want to share?
Bad. No problem. I'll just go.
I can. You want to share the screen?
No, it's okay. I've shared the screen. Can you see my whiteboard?
Yeah.
Okay. My whiteboard. Okay. So if we take this example where our input string is CBAC DCBC, and then we have this frequency count, which we said C will be 3, B will be 2, and D is 1, and A is 1, right? So first I will maintain a position, okay, which I will initialize to 0, and then I'll go in a for loop or so and start iterating this string. Okay, so every time from this position, okay, I will just look if this, whatever my current position I am on, this position, if this is greater than the I'm iterating through the string, right? So if this is greater than this one, so if I go from C to B, right? So my C is actually greater than B, right? So I'll increment my position to 1. And similarly here also, if I go from B to A, so this will be 2, correct? So now this is the least position. We cannot go more than that. And when I'm doing that, so I will always also decrement my frequency count because I've used C. So my C will be 2 in this case and B will be 1. And what I'm going to do when I'm going through this iteration, whenever my frequency count of any letter, okay, is going to be 0, then I break from that. So in this case, when I come at this position, the frequency count of A is going to be 0. So I can surely say that this is the last letter position, right? So this will be the only position what I'm having for this A. So I will just print this A over here. Okay, then what I will do with the remaining string, whatever the string is remaining, I'll just take this remaining string and find out if I have any position, any A in the others in the string. If I have any A, I'll just remove that string and again recursively do the same thing what I did for this string, right? So in this case, what I have, I will say this is my A, and then I will again recurse for this CDC BC. Okay, so in this CDC BC, I again do this. Okay, so now this is my S string CDC BC, and then again I'll find a frequency count over here for this. In this case, my, okay, I'm using this CDC. Okay, so I think I'm using too many of them, right? 1, 2, 3. So here it was 4, it is 3. Okay, so C will be 3 and D will be 1 and then B will be 1. Right, so the same thing I'm going to do again here. So my position, I'm starting from 0 and then I'm iterating from here. So C is greater than D in this case, right? So I'm not going to do anything. I'm just decrementing. So my position will remain here. I'll decrement C, so which will be 2. And then I go, so this will be 0 in this case when I compare this one. So my C, I'm comparing the C to be greater than this position. If it is greater, C is greater than D, no. So my position is not shifting, position will remain here. Okay, but my D is getting 0 in this case. So I'll just stop there. So I have this position now, I have C. Okay, so then again I remove this. This is my first one and this is my second C, right? And then again do for this remaining string again in the recursive order, then get the positions. So something similar to this, but it is we are using a recursive approach in this case.
Yeah.
So it's slightly difficult to follow. I think I'll show you the code, so that might be slightly easier. But I think
I have the iterative.
you have the iterative version for this one.
Yeah.
Okay. So do you want to go with that?
Yeah.
Okay, go ahead.
My screen is visible.
Yeah.
So I'm maintaining these two vectors. This is for the count. So here I'm just maintaining the frequency of each character in the string S. And this is the base case, like if it's an empty string, this will return it as it is. And for the answer, I'm maintaining this result as empty here. And first of all, I have like just appended my first character of the string, and I have marked it as true. Now coming into the loop, let's take an example.
Yeah, take a smaller one.
Okay, so as soon as I come into the loop, I decrement the count, and if it's visited, then I'm not appending that particular character in my string. I'll just continue. Now coming to this part, uh, so if I have a result, non-empty result, and if my current character is lesser than this, and if this is true, so basically let's go one by one here. So I come to B, my C is B here, and I go here. So this is true, but sorry, my B would already be there, right? I'm starting from 1, I equal to 1. So my character is C here. So my character is C here. So C is less than this.
The last
This
of the
is-
result back, right? So result is B in that case, correct?
Right. So this does not hold true.
Hmm.
So we come out of this while loop and we simply append C. So in my result, I have BC.
Okay, so you are saying your okay, you will be having B and C.
Right.
Okay.
In my result, I have initialized result as the first character, which is B here. And for the first character, I equal to 1, I just
Yeah,
add
that is a
C.
C. Okay.
Okay. Now coming to D, the same thing will happen. My C is greater than result of back. So I don't enter in this loop and I simply append D. And simultaneously, I'm also doing this. Visited of C equals to true. Basically, this is just to keep a track that I have taken care of its occurrence and I do not need to compute for the duplicate. We'll come to that later. Okay. Now I reach to A. Now, as soon as I reach to A, first of all, this is true, and my C is less than result of back. My C is A here, and my result of back is D, right? And my occurrence of the result of back is non-zero. So D is occurring twice, right, in this string.
Yeah.
So when the first time I saw a D, I decreased its count to 1. So I still have 1D. So because I have 1D that can come later on, I'll move into this loop. I'll first make that D as false and I'll pop it from the result. So after this, my result would be BC. Okay.
Mm-hmm.
Now I go into this loop again. Now my C is A, that is fixed, and my result of back is C. Sorry, my C is A, right? And my result of back is C. And this also holds true because I have 2 occurrences of C. Now again I pop C. So after the second, I will be left with B. And similarly for the third one, I'll be left with nothing. So as soon as I'm left with nothing, this would be false. And I come out of this while loop. And that is where I append this A here. So this becomes A. And for the rest of these, I'll simply append BCD. So
Yeah, because
at the end, it would become ABCD.
yeah, so the whole thing is like you are trying to find a letter, the first letter in this whole string, which has a single frequency or single count of frequency, and which is the lowest one first, right? The lexicographical
Right.
value.
Right. So basically, if I have something in my result array and I find something which is lesser than my result of back, and for the characters in my result array, there are more occurrences later on. So I'll take this, I'll try to start my string with the smaller character, just C, like A in this case.
Mm-hmm.
So I'll have to
Sorry,
remove
man.
whatever was there.
It's a little hard to follow in the example.
Yeah.
Okay.
So, but you know, the way it is, you know, so when you go for his example, what he's saying is B, C, D, A, B, C, you know, so the first letter will be B, that is for sure. But when you come for C, okay, so in that case, there is no other letter in C, right? So we just append C to that. Then
There's no other
we
letter
also,
in C. What does that mean?
oh, okay. So when you have first B will be your first answer, right? Okay. Then you go for C if you are traversing the string. So he's appending in B and C, and then he's doing that till D. Okay, because they are in the increasing order. Okay, because B is lower, C is second lower, and D is third lower. But when he comes to A, you know, because he still has B, C, D, because he has already frequency count of that, they are still there in the future string. So he can very well remove all the B, C, D because they are all smaller than A, correct? So he can keep that A,
Greater.
and that is the reason because A is the smallest one, and he has still B, C, D remaining in the other string. And therefore, when he goes for the next B, he can just use that because it is greater than A and also has a frequency count of only 1. Then in the second C, he has also frequency count of 1. That is only one letter what he has, and he has the D also of the same. That is the way the this will work. Correct, Harshit?
Yeah, absolutely.
So I think the monotonic stack approach is also similar to this, right?
Yeah, exactly. Like if you see the characters in the stack bigger than the current character, you just pop out all the characters from stack.
Okay. So for the
And
monotonic stack, what do you do? First, you have a frequency count also.
yeah,
Okay. So
I
Hey, I
have
have a quick
occurring activity.
question. So over here, the solution which Harshit shared, right? How does the example 2 work in that case then?
So
Because here you have like a continuously increasing, like ABCD, which is the second part of the string, is like these are in continuously increasing characters, right? But
okay, so in that case, what will happen for the second example? First, he will go with C, okay,
yeah,
then
you'll
with
remove
B,
it.
yeah, C, and then B. So B will remove C, okay.
Hmm.
So B will be at that position. When he comes to A, he will
Hmm.
also remove B because why they are
Correct.
removing B? Because B and C are still there present in the future string, correct?
Yeah.
So A will remove both of them. Then he will come to C. C also, there are future strings in that, but if you come C, because C is greater than A, so he doesn't want to remove C, right? So
Okay.
A and C are appended. Then when he comes to D, D is also greater than the C. So D will still be there. But when he comes to C, C is already been used for the
Yeah.
third C, right? So he's not going to put C in that. But when he comes to D, B, but B has
Shouldn't
only
you remove?
single frequency count. Yeah, go ahead.
Yeah, but like when you encounter the second C, wouldn't you like remove the D because you're like, okay, there's a.
Because he's putting the visited, right?
we have already seen one C. That's why you can't delete.
Oh, okay.
This is where that is done.
So that
I see.
visited
Yeah.
becomes very important. So yeah,
Mm.
actually this is
Okay.
very similar to the stack approach.
Yeah.
Yeah.
Okay. Thanks.
So in the stack, actually, we do the same thing, right? First, we have a frequency count for each and every alphabet letter. And then when we are actually putting them in a stack, first we see if it is already present in that. We'll have to maintain 3 data structures. One is a stack, one is a frequency count, and one is an unordered set.
Yeah.
Right. So set is for actually maintaining the unique letters, and the frequency count will be using a map, and then the stack will be using for the monotonic stack. Right.
Yeah,
Yeah.
something similar.
Right.
Okay. So yeah, if we go uh, the way what Shashank was explaining, if we have a stack, okay. So okay, you want to explain, Shashank?
Yeah, yeah, go ahead if you want. Like I'll share the screen. You can explain. Wait. Yeah.
No, you have already implemented, right? So you want to explain? That's
Okay,
fine.
code only. No, I thought that diagrammatic you'll go. That's it.
Okay, I'll try, son. So the first will be if you have a frequency map. Okay, let me go to annotate here. So if you have this map like okay, we have a frequency map, right? Frequency count here again for this string will have C 1, 2, 3, 4. And then for B we have 2, D we have 1, and A we have 1, right? And then we are going to maintain a stack. So if we take this example 2, so first we will be actually pushing C in this, right? So then we go for B. So we'll have to pop the C and then push B, correct?
Yeah.
Okay. So then we come to A. So when I'm pushing C, at that time I also am decreasing my frequency count. So this will be 3. And then when I push B, I also decrement my frequency count to 1. Okay. Then when I push A, so I'll have to again pop out B, correct?
Yeah.
So A will be in my, so A will be 0. So when in this case, my frequency count is 0, do I have to do anything? No, right?
No, it's done. Like you can remove that from there if you want, but no problem.
Yeah, but when I'm actually pushing that in the stack, so I am actually inserting it in the visited array also, right?
Well, yeah, so that next time you'll have to check. Last scene will be there, something like last occurrence. When did you? I mean, in set also, your scene also, you'll have to put which all things you have seen and what is the last occurrence of which element.
Yeah, so frequency count I'll use for the last occurrence.
Yeah,
Either you use a location or a frequency count. So
yeah.
now in this, when I'm putting C and B, okay, for the initial one, when I put that in my visited set,
Array.
yeah, so when I'm popping this out, then I'll have to remove that from the visited also, correct? So
Yeah.
because now we have only one A. So now when we have done with A, then we come with C, correct?
Yeah.
So then my C is not in the visited one, so I can push C on this one in the stack, correct?
Hmm.
Okay. And my D actually, if I look for the top of the stack, is still greater, so I can push D. Okay. So, but now when I come to, in this case, when I'm coming to C, right? Okay, I didn't write this one over here. So if this is C, B, A, C, D, C, B, C. So I'm here. So when I come to this C, I see my C is already there because I'm maintaining another visited unordered
Set.
set. Yeah. So my C is already there. So I'm going to skip this C. Okay. Then I just go to B. So in that case, I see B is not there in my visited set. So I'll push B on here. Okay. And then I go to C. I don't find that. I find that in the visited one. Correct. So then I'll skip this guy also. Right. So my monotonic stack will actually maintain the subsequence, and that will be the lexicographically the least one, correct? Because
Yeah.
I'm always comparing the top of the stack, and always the letters on the top, they are all in the increasing order, or their frequency count is only Z1 or whatever the least one, correct? And they are not being seen anywhere else.
So
And then
three.
when I actually pop out from the stack, I will actually form a string like A, C, D, B.
I have a follow up here. So if the string was CBACD, CB,
Let us take that example. Okay. What do you want to say?
no, the example 2. Let's start with the example 2 string itself. CBACD, C. One second. Basically, I'm trying to see, like, in the future, if we again A, C, D, B we are getting, right? So, okay. So if after this C, we actually see a D again, then No, we are going to be removing the second, the 1, 2, 3, 4, the fourth CD, right? Then at that point, and we'll be inserting the last one. Is that how it goes?
No, if you this is the only string, what will happen? We have only one B here, right? So
Yeah.
we'll have to take this B first.
Oh, so we are going to get it as BACD.
Right, right.
Okay, fine. Okay.
Because we still have to maintain that
Got it.
sequence. Yeah.
Yeah.
They're trying to kind of
So if the frequency is one, you'll have to keep it. And secondly, like if you have
Yeah.
already
Cool. Thank you.
Hey, that does not look like a monotonic span.
yeah, not exactly, but
It's not. It has. We are just taking help of the monotonic stack to some extent, but it has to be modified. It's slightly modified in that. We have to take help of monotonic stack.
yeah, concept is that only almost.
Yeah. So, monotonic stack, usually what we do is whenever we look at the top, and if we see the top value, if it is greater than the current value, what we are going to insert, then we pop out, right? But in this
Yeah,
case, we don't have to pop, even if it is valid case, but we'll have to look if the frequency count, is greater than 1.
one.
Okay. Yeah, so then only we have to pop out. If the frequency count is not greater than 1, we cannot pop. So that is the reason we are actually having a different version of monotonic stack.
It's a kind of hybrid, like everything we are taking care. But the main thing is like on monotonic stack itself, right?
Yeah, you have to take help of that monotonic stack,
Yeah.
but it is slightly, change in that. So here again, if we take this example, so if we have a frequency count, we'll have C will be 3, correct? So we'll have B1, A1, and we'll have D2, correct? So then if we start with and then we'll have a visited array, okay, visited set. So when we start with C, in the stack, we first will have C, okay, then we come to B. So now B is greater than C, so C will be 2.
Okay.
But B actually, when we go inside, okay, okay, so C will be visited also. So if we maintain this, so we will have C there. Then when we go for B, B is not present. So then we will put that in the visited. But if we try to look for B and C, okay, in the stack we have C, correct? So we cannot pop out B, C, because our B's count, because we cannot pop, because the B count actually, yeah, actually we can pop out B, right? Yes, we can pop out C and then we have to push B, correct? So we'll remove C from there. Then we are pushing B, okay, and then we have inserted this one also here. So this becomes 0. Okay, then when we come to the next one, A, okay, so when we come to A is not visited, so we put that in visited, and we also make its frequency count to 0, and then we push A on top, okay, but we cannot actually pop out B because our frequency count of B is 0, correct? So then we push A on the stack. So now our, so this is, yeah, so I think,
Yeah, sorry for bad connection right today.
okay, so what was the example we were going through? It was something like we had example, some input was C, B, A, C, D,
CD.
right? C, what was that? C, B, A, C?
CB, ACD, CD, I think again.
Okay, CD, right? So okay, the frequency count in this case will be something like C will be 3, B will be 1, A will be 1, and D is 2, and our visit array, right? And so this was my stack. In this case, the first one actually I put in C, okay? So this went to 2, so I removed that when I got for the next B, and then I put in B in this case. So I made this 0. So now this B doesn't go out from the stack at all. Okay, so I'll just put it here instead of putting it here. just ignore this guy for now. And then I go to A when so my C was here and then B was here. So I can remove the C because it has popped out from the stack. So I put in B. And then when I come to A, so A becomes 0, right? Then I push A in this one. Okay. So then when I push A in this, then I look for C. So C anyway is greater than A. Okay. So again, it becomes 1 and it is not in the visited. So I put that. So I have C in this one. Okay. Then I go for D. Okay. So D is also not there. So decrement that. So I put this D over here and then I push D in this case. Okay. So now when I come to C, okay, so now C is greater than D, correct? So I have to actually pop out D, but right. So when I'm done with this, so but when I come here, this guy is 0, and I already see C there in the visit, so I don't pop out C. I push D on top, so D is already there. So I don't actually, because my C is still there in the visit, so I don't ignore C here. And then when I go for D, so D is also here, so I ignore D. So in this case, my sequence will be B, A, C, D.
Right.
Yeah, I should have added A also in this case here. Yeah. So that is the reason we'll have to take help of one is the map, which will be the frequency count. This will be an unordered set or something like that to maintain the visited elements, and this will be the stack, correct?
Yeah.
Yeah.
So the stack will be monotonic, increasing to the extent only when a frequency count is greater than 0,
1.
right? Yeah, 1 or greater than 0.
1.
Yeah, so we still have feature elements. And if the frequency count is 0, then we cannot do anything. We are not going to pop anything from the stack, but we can push our other elements into the stack, provided they are not present in the visited set. So we have to look at all the 3 conditions.
It's a good mix of everything. Like all the 3 data structures are coming here.
Yeah.
Mm.
Yeah. So
Yeah.
you want to share that code
Yeah, sure.
or?
I can share it. Yeah, so this is the stack which I'm having, and this is the visited set and last occurrence, like frequency, what you are telling. So corresponding to each character, I'm tracking at which point which character is there. And while going through each of the characters in the string, I check if I have already seen that particular character, then I'll continue. I won't do anything. And here I'm checking as long as my stack is not empty and top of the stack is greater than this, and last occurrence of this should be greater than your I. The wherever your previously wherever you have seen the character at which position, and if the top of that character's index, if you take, if this is greater than this, then in that case we are copying, and then we are removing that particular character from the, what you say, scene, from the visited set. And just after, I mean, we keep on doing that, and once we find that new character we are adding, then we'll add it to the set, and then what do you say, add it to the stack, and just after that all the elements you take out of the stack and form a string out of it.
Okay, so you are using the last occurrence, which is not a frequency count, but it is the last index of that particular character, right?
Character, yeah.
Okay,
In
so
that
in
case,
that
otherwise,
case,
if you
yeah,
use frequency, I have to decrease each time its frequency by 1
yeah,
till
yeah. So you're trying to avoid that. So you just look at what your current index is, right? So in your for loop, when you're actually iterating using with that index I, so you look for that index. If that index actually is lower than your last
top of
occurrence, then only you pop, right?
top. Yeah.
So that means you have few more of those letters in the future part of the string. That is
Yeah.
the reason
Yeah.
you can you it's valid, to pop those elements from the stack.
It should be overall O of n only, right?
Yeah. Other than the O of m, it's very difficult to understand. So at that
We are
time,
visiting each character only once of the string on that
No,
basis.
twice.
yeah, but we are consuming a lot of space in that case.
Yes, yeah. So how we are visiting twice? Oh, if it is repeating, then only, right?
Yeah, you're right. We are visiting just once.
Yeah.
We are visiting once, but actually the space complexity is more.
No, yeah. So can we optimize this space?
So we need a frequency count, we need a visited array, as well as we need a last occurrence.
Yeah.
At least for this, the way they have
Done till
implemented,
now.
right? Yeah.
The space is also constant, right? We are using a 26 size array.
Okay, if we use a 26 array, a 26 count array.
In the stack also, like it would be maximum 26 only, I think.
No, but length of the character string can be anything, right?
Right. But that is a part of your answer, right? You have to return. So that won't count as space complexity.
No,
Yeah,
he's
but
saying when stack is, stack will be 26, maximum will be 26, yeah.
No, scene would be 26. Stack is being used to form your output string, right? So that can be anything. That depends on n.
No, but you at max you will have only unique string, unique letters, right? So the max unique letters will be 26.
26, yeah.
So anyone has any other implementation or same one in a different?
Yeah, this one's exactly same like the way I have done. Only the last occurrence part is added differently.
Yeah, that's the one which you have shared. But there also you are having using these many, right? You are using as rather than stack, you are using a vector. Yeah.
Right. Everything is same.
So what are you using?
So I'm using a vector of size 256 instead of the stack and set.
Oh, okay. So the implementation what you were discussing earlier. Okay.
Why 256? What was the?
I thought we can have that other special characters also.
Okay. Your underscore capital, all those things, right?
Yeah.
No, but they mentioned like it will have only lower. Yeah. Okay.
Okay. So
Yeah,
do we want to go in any other implementation? Want to discuss about that? Or? I think they should be fine, right?
Too much of implementation again, like it will.
But is it clear? I doubt. Like, is the whole thing clear now?
Like lot many conditions are. I mean, overall only 3 conditions are there, right? When will you pop and when will you insert, right? Only 2 things you need to remember, right?
Yeah, basically the idea is to keep the left part of a string as small as possible. What we are returning, we want to keep that as small as possible, provided we have occurrence of that characters later on in the string.
Yeah.
So if we have occurrence of that particular letter only once, we start with that, right? So that is the one which will be the first one. And if we have the occurrence of that same letter in the future part of the string, we can ignore it, right?
Ignore it, yeah.
Based on what is the previous letter in the string, in the output string.
Yeah. Otherwise, monotonic stack property follow in the rest of the cases. So only 2 cases are there. No, like if you have frequency 1, then in that case you start from there. And if the character is repeating, don't do anything. Otherwise, the rest is like what we already know, monotonic one.
Yeah. So any other questions?
Sorry to ask, but just want to get can you just quickly tell about why we are using visited? like can we not skip visited?
Well, visited, okay, so the visited is used. That's a good question though.
If that character has already been included in output string, then to just avoid that again, we are using visited.
But if we have already appended in the output string, which means its frequency count is 0 already.
Not
One,
necessarily.
one it will be. Not. No,
So,
it need not be one also. It can be anything, right?
so
No.
it can be 1 or maybe 0, or if you're following the monotonic stack principle, right? In that case, you'll have to push that string. Correct.
Yeah.
Okay.
Yeah, so it can that there can be multiple occurrences of that character, but once if we have included it in our stack in this case, then we need not consider it again.
Yeah, so if you take the example two, so we have C. If first we are pushing A because that is the least one, then we immediately push C. Because if we look for the monotonic stack, it's increasing, right? So we can push C. That is a valid one, and then so we'll put that in the scene in this case, right? So we are putting that in the scene, so we don't want to use that C later, right? So then when we come to D, so then when we come to D, D again is greater than C, so it can easily go there. We don't have to pop out anything, right? So D is still greater than the top of the stack, which will be C. So D goes there, but when you come to C again, so it is already there in the stack, in the stack, right? So we don't have to push C.
Oh, okay.
So if it is there in the stack, we don't want to push, and that is the only reason we are using C.
Okay, got it.
Instead of stack, if we would have used something like a different implementation, something like unordered set, so we could have easily seen, okay, it is there, so we could have avoided this. But then we'll have to still maintain the order, right? When we want to pop out for the output. So that is the reason we are using the stack here.
Okay.
Yeah, let's move on.
Yeah. Okay then. So next is like maximum product subarray. So given an array of nums, find the continuous subarray within an array containing at least one number which has the largest product. So for this 6, like these two we are taking, and here none of them. I mean, -2, -1 you can't take. They are not a subarray. Yeah. Yeah. So like, what would be the brute force here?
Okay, so this max product subarray is we have an input of integers which can be negative numbers, zeros, right? And there is no constraint on how much length it's going to be and all that stuff, right? Because we are actually we are supposed to return the product, correct?
Yeah.
So we might have an overflow and all those stuff. So there's nothing mentioned here. Okay, so we are assuming there won't be any overflow. Okay, right?
Yeah.
Okay. So then to do it the brute force way would be like go through each and every input what you say element, and then multiply by each and every one, and then find whichever is the maximum product. Usually if we have negative and positives, whenever we are multiplying that with the negative number, it will be lesser than that, so we can ignore it. And if it is 0, then we'll have to take special precautions there. Right, yeah. So the brute force would be just go through each and every element, and then in another loop, like you can have a outer loop starting with all these indexes, from 0 to n minus 1. And then inside you can start from 1 to n minus 1, right? So you can multiply the first element, starting with the next, and then keep on multiplying and store the max of r, also max of r product every time. And then at the end, whenever you find that, you just return it.
Return the max product, yeah.
So that will be n square, correct?
Yeah, and if you find 0 somewhere, and then you can skip that also. Little bit of optimization, right?
Right. So if we do this way, like if we have 2, 3, minus 2, 4. So first I will start with 2. Okay, so that will be my max product. So then I will multiply it by 3, which will be 6. That will be my max product. So if I multiply by minus 2, okay, so then it is going to be lesser than that. So I actually ignore this, right? Then I multiply by 4, which will be 24. So this will be my answer, right? 24. Oh, but it has to be a contiguous subarray.
Yeah.
Contiguous, yeah. So max, again, you have to initialize the product to 1.
Yeah,
Okay.
I don't simply ignore the negative one.
Sorry, hi guys. So if the two negative numbers come in sequence, then there would be a problem if we ignore the negative number.
Right. Yeah, so actually this won't work in that case. So we can keep 6 as a max of r, but when we get to minus 2, so then we just start from the 4, or we just start from minus 2. Okay, even if it is not the least one, right? Because we already have added this 6. No?
Yeah.
So because if we have something after 4, in this case like 3, so that would be the maximum subarray, right? So if we say minus 2 multiplied by 4 will be minus 8. Okay, and if we keep that minus 2 sign still, right? So again we'll have to do 3, which will be minus 24. So, but we won't be able to get 12.
Right.
So then how do we go about that?
So odd number of minus, if you see, then you reinitialize your product from there. No, you keep a track of previous minimum product also, right?
Yeah, we
Hey,
have a lot of options on.
so, hello.
Yeah.
Hi. There's one approach probably that might work is, let's say the example is 2, 3, minus 2, and minus 4, for example.
Okay, you are saying 2, 3.
Minus 2, minus 4.
Mm-hmm.
So what we can do is, I'm just thinking. I don't have a solution, a coded solution for this. We can start with 2 and then continue multiplying till the end of array. And then see, at every step we can see what's the maximum at this point. And then we can record a maximum.
So you are saying multiply 2 by 3 and then 2 by...
So 2 by 3 is 6, right?
Right.
So current max is 6. Then we multiply it by minus 2. Current max is still 6.
So you multiply 6 by minus 2 or 2 by minus 2? 6
by minus 2.
Okay, 6 by minus 2.
So it will be minus 12.
Yeah, okay.
And then current max is still 6, and running product is minus 12. Right. Then you multiply it by minus 4. Then it becomes minus 48. Oh, sorry, plus 48.
Right.
Which is more than 6. So we record this as maximum. And then, so in the next iteration, what we can do is, since we are removing the first element, we can divide this 48 by 2. And then it will...
Oh, so you're saying when we go to the next one, you take the starting one to be 24?
Yeah, so I'm taking a sliding window, which is, when I'm removing I'm moving to the next index. I'll divide it by the index, the element in the index 0, because I'm now removing it from my equation, right? So now standing at 3, the current product will become 24, because I'll divide 48 by 2 because I'm removing 2. So now 24 is still lesser than 48, so I'll maintain 48 as a maximum. And
Okay, but what do you do with the 24? So it is still 48 is more than you just ignore 24, correct?
I'm ignoring 24, yes.
Yeah.
And then when I move to the next, I'll divide this 24 again by 3.
Okay, so you come here and then you divide this by 3, so you will have 8. Yeah, so in this case it's the same thing. Then you actually divide this by -2, right? And then you come something
Yes,
like
I mean it may
-4.
not be
Yeah,
may not be a good example, because
that's right.
let's add 12 at the end, and then
Yeah, if we have 12, then then it will be more than this one, right? So yeah, so what you're trying to do is trying to find the minimum element, right, at every time, as well as the maximum element.
yeah, so it's a little optimization from brute force, where in brute force you were doing, you were taking every element and then multiplying it again, because multiplication was already done in the previous iteration.
Yeah.
So what I'm saying is we can leverage that.
Right.
Does that make sense?
Yeah, it makes sense. Yeah.
Okay.
Variant of Kadane's algorithm, right? Somewhat, not exactly.
Right. So that algorithm, we use it for max subarray, right?
Yeah.
You're finding the maximum sum. But here we are actually having the product, because in that case, your sum, if it is going lower than a 0, we just make that sum to be, initialize it again, reset it to 0 value, and then go from there, right? So that is very easy to do. But in the product, when we actually reset it to 1, but if we get 0 also in our input, then actually the whole thing messes up.
Yeah.
Right? So
Yeah,
we can take help of that. And so in that case, if we find something like a minimum and maximum values every time whenever we are at a particular index, right? And then actually we keep on moving with that max min, and then find out which is the best out of that. Correct. So then we should be able to. So what they say, we can have something like a max P and min P every time. So if we go by the first example, 2, 3 minus 4, so we initialize max P to 2 value and min P to 2 value. And every time when we are finding, we can actually find something like starting from now 3, So in this case, what we can do is we can find something a max temporary, we can say here, and then we find, we can take this num value, which is 3, okay, and then we can use this max P and multiply by 3. So 2 multiplied by 3, right? And then we can also multiply this min P, which is 2, and again by 3. So, and then we find out which is the maximum out of this. So in this case, it is 6. So we just assign 6 to max T. And then we also find minimum T, which will also be almost the same here in this case. So we can take this. So now the max P is not increasing, right? So it is same here. And then again, it is same, right? And this is also 2 into 3. So, but in this case, we find the minimum. So in this case, the minimum is 3, correct?
Yeah.
Okay, and then we assign these max P in this case now will be 6, right? And the min P will be
3.
Min P, is it going to be, it's not going to be lesser than that, right? So we have to increment that also. So this will be 3, right? And then we actually store something like a real max value. In this case, the max value will be whatever we get from here. So this will be 6. This will be our answer actually. Okay, if we call this as answer instead of max v. And then when we have done with the 3, then we go to -2. In the same case, so this will be -2, right? And this will be -2, and this will be -2. So in this case, the max of this will be -2, -4, -2. So max 2 will be -2 in this case, correct?
You'll multiply with the product, no? -2.
I'm just, 1 minute. I'll just remove all this stuff so it confuse. Sorry, what you're saying?
I was saying -2 you will multiply with the minimum product and maximum product, right? Or with the 2 itself will multiply -2.
So because now I'm in this loop, right? So when I'm going to the -2 index, okay, if I'm at this one, so I'm in this sort of a loop here. Okay, so
Yeah,
when I go to -2 here, so I'll have to find another max and min also in this case using this index, using this value, right? -2. So if I use this, okay, you are saying I have to multiply this by 6, correct? Yeah.
yeah. Because otherwise it will not be a subarray if you multiply
Right.
2.
Yeah, let me erase this whole thing. So that, yeah.
Then
So
you
in this
product.
again, you find all of this. So now you will have -2, and then you will have 6 into -2, correct?
Yeah.
And then you will have 3 into -2.
2.
So our least value, the max value will be -2, correct? So this will be our
Yeah.
max value. And so for the min value, we have to do the same thing, which is -2. And 6 minus 2 will be -12. And 3 minus 2 will be -6. So this will be our minimum value, correct?
Yeah.
Okay. And then we have to again
4.
append these values. And now in this case, which is the maximum of this and this? So it's still 6 is the maximum. So we are not going to change this, but we'll have to replace this with -2 and -12, right?
This is your global max, the answer at the top down.
Yeah, this will be my output, right? Then I actually do the same thing again for my last one, right? So in that
Yeah.
case, so if I go for 4,
4.
4, and then I have 4 multiplied by -2, okay? And then I have 4 multiplied by -12, correct? So
Okay.
in this case, these are all negative, so they won't be the max. So my 4 will be the max in this case. And then if I do the minimum for this, I think 4 minus 12, which will be 4 minus, sorry, the min. So it will be 4 minus 12 will be -48, right? So
Yeah.
this is 4 minus 2 is -8. So -48 is the min. So even if I just modify these to 4 and -48, right? So, but my still answer is 6 because I just have to take the max of max t and answer at any point of time. So my answer 6 is still greater, and therefore I can return 6 from here.
Yeah.
Right?
So, like, what is the intuition for maintaining max p and min p every time?
Because
Like
we are having negative numbers also, right? And we
yeah.
will come across any zeros also. So if we take the max and min every time, so because if we have a min value, right, and then it's like a negative value, and then we have another negative value, so that will make it a positive, right? So when
Positive.
I come here in the max, so at that time if I have two negative values, that will be a max value, right?
Yeah.
So I cannot ignore the negative values also. So that is the reason we'll have to use the max and min every time.
Yeah, makes sense. And then keep on updating the global maximum.
Yes, yeah.
Yeah. Yeah, so you want to share the code like?
No, yeah. So you can go ahead. I think you had
Yeah.
that, right? Yeah.
This one I was but I couldn't get much in this, like why or operation they are doing here. I mean, first I'm reversing the array, okay, and now for every like going from 1 to length of a, I'm creating the suffix of a of I and prefix of b of I, right?
No, I didn't get that. Why it is so?
This is the suffix that I'm creating, but I myself couldn't get like why or operation they are doing. Like I checked in the solution, but
Okay, so let's come to that later. Let me at least quickly share the way
yeah,
I was
max.
showing. Yeah.
Yeah.
Are you able to see my screen? Hello?
Yeah.
Yeah. Well, so this is the way I was discussing. Um, so I have these three variables defined. One is the max p, min p, and then I'm using something like a best or answer, whatever you can say. And then I'm initializing that with the first element, the nums, and iterating through the rest of the elements in that array. And at any point of time, I'm just finding another max, a temporary max for this current one. So for that, I'm using this candidate as like the current element, and then the max, the current element with the global max, and the current element with the global min. So every time I'm finding the max value of all these three, as well as I'm finding the min value of all the three, and then I'm updating my global max and min with these values. And I'm actually trying to find whichever, because max p will always be max, right? So you just have to take the max p with my current answer, right? So just have to find whichever is the max.
Yeah.
Yeah, so something like that. So this is the way I think this was at least easier way to understand.
Yeah, intuitive it sounds.
Yeah,
It's
it
like
is.
some slight variation of Kadane's algorithm only. Like there we keep one variable, here we are keeping both max and min. There we are keeping only track of max, right?
Right.
Yeah.
So the way why they are doing year min, because only of that negative value, right?
1 0. Yeah.
Okay.
Next, I mean, even number of it negative comes, it can make product positive.
This includes, can you paste this one on Discord whenever you get time? I mean, this one is very neat actually, the explanation wise.
Okay, sure.
Yeah, that is intuitive. Yeah. This one I couldn't get. Like they were trying to make suffix and prefix, and whenever they find uh,
Example.
Okay, so
yeah,
he's trying to do a suffix.
yeah,
Okay.
first one, and B is inverse of array one. I mean, first array itself. So
Okay,
he's
so
trying to create. Yeah, go ahead.
okay, so you're just inverting the array. So 2 3 minus 2 4 will be 4 minus 2 3 2, right?
Yeah.
Okay, and then you are actually ORing with 1. That is nothing to do with because if you have a 0, then you have to OR with 1, right? So there it will help.
Yeah, for zero.
Okay. So if I write it here, okay. So your input array is 2, 3. So I'll just reverse it. It will be 4 minus 2 and 3 and 2, right? So in this case, when we are actually going through the whole, the first for loop, which is on line 4 to 6. So my A, what it is going to be? So 4 multiplied by, I will be start from 1, right? So you're starting, so 4 as is. Okay, then 4 minus 2 will be minus 8, correct? Okay.
A of I equal to A of I into A of I minus 1. Okay, yeah, minus 8, correct.
No, this is B, right? What you have written above.
Okay. So yeah, this will be B. So I will have to maintain A also, right? Okay, so we'll come to that A later. So let us finish with B. And A minus 8, 3 will be minus 24, right? And minus 48. And so if you go via A, so A2 will be as is, correct? So we'll have 2 into 3 will be 6. And 6 minus 2 will be minus 12. And minus 12, 4 will be minus 48.
Yeah.
Correct. And then he's saying that you go through each and every one and find out whichever is a max value, right?
Take that, yeah.
Okay. So just go through each and every index again.
6 is the max.
Is it like that?
Yeah, 4 plus 2, 6. 6 is the max.
But no, if you look at your line number 27, he's saying return max of A plus B.
Yeah, you add these two array element wise, like 4 plus 2, 6, minus 8 plus 6 will be minus 2. And minus 24 plus 12 will be minus 36. And that will be 96, minus 96. So max is your 6 only, right?
Right. So you add all of them. So this will be minus 2, this will be something like minus 36, and this will be 96. So in this, it will be 6. Yeah, this is a good one. But yeah, it's very...
I mean, coming up with this is not like, I mean, what you say, straightforward.
Yeah.
How they got it, yeah. And OR operation we didn't use here. If 0 and all will be there, then I think in that case.
Yeah, if you go for the second example, minus 2, 0, minus 1, in that case, that OR 1 will come.
Yeah. So,
Right.
but what is the intuition here, like getting suffix and prefix and then adding them? Like, I mean, result we are getting mathematically by walking through the code, but like it looks like non-intuitive.
So he's still finding.
Is it like when you reach minus 2, you take all the products before that number and after that number, right? I mean, at ith index, if you are like when you are at this index, so you are taking what is the product till before this and what are the product after this, and we are clubbing those two, right? This is what is happening because that. Or am I lacking? I think somewhere. Minus 2, 4 we are having.
Yeah, that is not very clear. So I didn't understand one thing, why we have to add these two numbers also, right? So when we are adding, so even if we say, okay, this 4 is the last one and the 2 is the first one, but they are not a contiguous subarrays, right? So that wasn't clear though. Even the answer makes sense.
Yeah, but not intuitive it is. No, it's like, see, when you, 4 you got, right? Okay.
Why is it adding?
Yeah, I didn't get that. Why it's
I
adding.
also, I mean, I was trying to look into that, but I couldn't. Adding reason is 4 here and.
And I mean,
Yeah.
we can also have a subarray which is in between, right?
Yeah, like between last and end. Yeah, intermediate, right?
Yeah.
Yeah, but that, whichever will be maximum, that will give you.
But this will always like A of I and B of I would be a prefix kind of thing, right? Like cumulative.
Yeah, one is prefix, other is suffix.
Yeah, so it will always start from the beginning in case of A, and for B it would be from the end.
Last to one. Yeah.
Yeah, it's something
I'm not getting why we have to add that is for right. Yeah, but it looks good one.
Nice.
like, was there any
Did
explanation?
you submit this already?
Yeah, yeah, it's working. Yeah, explanation was there. I'll open it, but I couldn't get. They tried in explanation. What I got is they are trying to calculate the suffix and prefix. Yeah, this. Sorry. See, calculate the prefix in product and suffix and return the max. That's it. Explanation there. This is the code. But I don't know why.
Yeah,
And then I
prefix product and the suffix.
see. First, if there is no zero in the array, then sub array with maximum product must start with the first element or end with last element. And therefore, the maximum product must be some prefix product or suffix product. So in this solution, we compute the prefix product A and suffix product B. Proof they have given here.
Yeah, I would go by the normal one. What
Yeah, that is that is
in
more
the
intuitive also.
yeah, it is in the solution also, and yeah, it's like a modified version of that Kazan's algorithm.
Kazan's algorithm. Yeah. I don't know how this is.
Yeah, maybe it will require extra efforts to go in that and find out. Yeah.
Yeah, we can go to next.
Yeah.
We'll check it. I'll share the link if somebody can come up with this.
Sure.
Yeah, then we can switch to next, right?
Yeah.
Okay. Yeah, so our next is like given a binary tree and a sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals the given sum. A leaf is a node with no children. So given the below binary tree and the sum. So like this path 5, 4, 9, 20, 22. So this path is containing the sum, what they are saying. I mean target.
Okay.
Yeah.
So this is a binary tree. So we will be given a binary tree root node, and then we'll be given a sum. And so we'll have to find the sum in any of the path which starts from the root to its leaf, any of its
Yeah.
leaf, right?
Any of it. Yeah.
Yeah. So in that case, and do we have any constraints? Nothing like that. So it's only we'll have to go from a root to the leaf. We cannot actually have anything from any node to any node. It has to always be from root to leaf.
Yeah.
Right. So in that case, it is always a straightforward DFS approach.
Yeah. Go.
Looks like, right? Yeah.
Either you keep on adding the nodes or keep on reducing the sum. The moment you find sum is 0, you got that path. Or if you find your sum equal to target.
Yeah. Or you can do iterative also. You can use a BFS approach. Correct?
DFS should be better, right?
Yeah, but DFS is fine. But we could go with the BFS approach or no. I'm just thinking loud. Yeah, but DFS is, yeah.
Intuitive looks, yeah. Yeah, BFS. So BFS 5 you will enter first, and then its children you will pop 5, and 4 and 8 will go inside, right?
Right. So you'll have to subtract every time and see if it is lesser than the sum. Right.
So
So
25 minus, okay.
So whenever you actually pop out, then you actually check that with your keep a current sum always. But when your current sum will be actually something to be the same as the sum what you has been in the input, and it's a leaf. Okay, so you are at leaf position. So you can say, okay, I am now. This is my sum, right? Then you can return true from that case.
Yeah.
So, but you cannot maintain a queue in that case, right?
Queue, yeah, that looks like in.
No, I don't think so. It's a BFS. It will still be a DFS only. Yeah.
BFS only, yeah.
Yeah. It's not possible to find
Or
using the
maybe
DFS.
whenever you pop a number from Q, if you subtract from your sum and if it is giving you negative, no,
Yeah.
but it's not possible.
Maybe
No.
we'll have to use a pair in a queue. One will be the tree node, and the other will be your current sum till that position. Correct. So that in
Yeah.
that case it might work. But you'll
Might
have to traverse the whole tree because whenever you find that sum equals 0. Yeah, I think that should also be possible. Yeah, but the DFS will be the easiest way to do, right?
straightforward. Yeah, exactly. So I've used DFS only. So if the root itself is not there, then false. And first time you hit the root, I subtracted that value from my sum. And this is the base case where I'll return. If I find my sum is 0 and I have reached the leaf also, then I'll return true. And recursively just go for both root dot right and root dot left.
Yeah, makes sense.
Yeah.
So if we do the BFS way, what we can do in a queue, we can start with the tree node, the first one, okay, and at that time we can actually put whatever the sum is, right? So we can actually put 5 and 22. Means I'm saying it will be a tree node actually, right? So which will have a value 5 along with the sum 22. And then when you come in the while loop, when you're actually accessing the queue for the first time, actually pop out whatever is there in the queue if it's not empty, and look for those it's two subtrees, right? The left and right.
4 and 8, yes.
Yeah, and then in that case, you actually subtract this value, whatever is the roots value from that sum, and then put on in the 5 and if we can quickly go through that this way, right? So if we first enter 5, and so 5 is a tree node actually, okay, and then we say 22. So then when we come in the queue, so we'll have two ones, right? So one will be the left and right. So what we can do is we can put 4 in that case, and we have already 5. So 22 minus 5
17
will be 17. Yeah, right. This is one pair, and the second one will be 8. Okay, 8 again 17, right?
both of, yeah.
Both of them will be 17, and then you come here again. So in this case, when you come here, so 17. So we'll actually push 11 in this case.
11 13, yeah.
First will be 11, and this will be 13, correct?
Yeah.
So this doesn't have a right subtree, so we just ignore it. So when we go for 8, so we'll have a 13, that is a
7 9.
subtree, and 17 minus 8 will be 9, okay? And then we'll have another one, which will be 4. This is a tree node, right, again? And
4
this
9.
will be 9, right?
Yeah.
So when we come to 11 and 13 in this case, so we'll have 7, and 7 minus 11 will be 2, right?
Yeah.
And you will have 2 in this case, 2, and this will also be 2, correct?
You got the
Right.
correct form. Yeah.
Yeah, so when we actually come in the loop, we will be seeing these 2 and 2 are same, so we can actually get that.
Return.
Yeah,
Yeah.
and again, if you want, we can go ahead also. So yeah, BFS also should work, right?
Yeah. Now
Using the
it
queue.
looks.
But what we forgot to check whether this is a leaf node yet or not, right?
Oh, yeah.
Yeah, we'll have to check. Yeah, whenever you are popping out in the BFS, at the queue level, when we pop out at that time, because we are not actually going to return from here. So when we go to the loop queue and then we pop this 2, and then we check if this is 0 and also it is a leaf, then only we return true. Yeah, that is right. That is the condition we'll have to check.
Why don't
Without
we only one?
without pushing 22, it's not possible. Like 22, I'll keep outside only, and whenever I pop something from queue, I'll subtract from 22. But yeah, but this is giving a correct. I mean, all the what do you say? All the possible paths you're visiting and checking.
Yeah, it should work, I think. Yeah.
No, it will not work, I think. But because here at every step, pair of values you are checking while popping out itself, right?
Yeah, so actually these are ones what I'm pushing. So this is at one level, right? Okay, so level 1. So this is at level 2 and this is at level 3. So this will be at level 4. So I'll have many of them. So when I use this level 4, okay, when I come to the queue, first I'll pop out 7 and 2, right? So 7 and 2, it is not going to be 0 and it is still a leaf. So I'm not going to return anything. Okay, so then I
Yeah.
come to 2 and 2. So in this case, it will be 0, right? And this is a leaf. So I can easily return from here as saying it is true. And even if in this case, if it would have been 3, okay, so I'm just taking an example where it is not satisfying the sum. Okay, so even if
Okay.
I complete all these whatever the elements in the level 4, and if I don't find, so at the end I'm going to return false, right?
Yeah.
In case
Yeah.
if this was instead of 2 it was 3, correct?
Then yeah, in that case,
Yeah, so this should work, I think. Maybe even it will be.
bit I mean, little bit like no, it's not complex. Normal BFS, right? Only couple of values you are passing. That's it. And
Yeah,
couple of
but
cases you check.
right, but it's like we are storing the tree node as well as the value every time, so space complexity might be slightly more, but yeah,
And
should be
also
possible.
runtime. Also, we'll have to iterate through all the nodes in this. If we go by BFS.
Yeah,
DFS, yeah, that's a
agreed.
good point.
Yeah.
But
If
overall, it
it's
will be
DFS,
open only.
yeah, big of n. But if it's DFS, then it's big of log n. So that's much better.
Absolutely, agreed.
Yeah.
No, but let's say a DFS, since you got in one path, let's say you didn't get, then again you'll revert back and take another path,
But
and
still it
again
is,
revert.
yeah, but average it will be log of n. In
Hmm.
worst case, it might not be. In
Yeah.
worst case, it will be still O of n.
Hmm.
Yeah,
Yeah,
but
here
in,
average
in
is
this case, it will be more than log n always, in the
log
average
n.
case also.
Yeah.
Unless you have something which is only on this peripheral, but still you have to form all of them, right? So every time you have to go through each and every level. That will be a bit. That's a good
Yeah.
point. So therefore, they actually don't opt for BFS in
DFS.
such cases. Yeah,
Yeah.
makes sense.
Why can't we do with a single element? You took a pair, right?
But
What was
in
it?
single element, you are always subtracting from the same target itself. I mean, target is being different for every element when you put pair of values, right?
So single element, we could, but the only thing is we also need to know what is the sum, right? So at the every level and every node, the sum will be different.
Yeah.
That was the reason actually went for a pair.
Because from 20 you'll subtract 4 also and 8 also, but there different thing was happening. I mean,
Right.
yeah.
I mean, I was thinking instead of subtracting, why don't we add
and anytime I get a value which is equal to 22, I'll check if that's the leaf node and
Yeah,
return
that
true.
Yeah, that
that
is
could
also
also.
possible. Yeah.
But then 0 you will pass in that case, tuple of values.
Yeah, you'll have to start with 0 and then keep on adding it. Yeah.
But without tuple, I don't think so. Single value by passing it will work, because at every level your sum will be different, and for every nodes also.
Yeah.
Yeah.
Okay.
Yeah, sure. Can wrap it up. So anyone has BFS?
I think yours DFS was the same, right?
Yeah.
Yeah.
It was only one. I also did the similar way. You
Yeah.
just subtract your sum always from the root value, and if it is 0 and you have both of them as tree, then only you return true.
Otherwise, again, then keep on
Yeah.
doing same
Yeah.
thing.
Yep.
Yeah, sure. Yeah, then we can close it.
Okay, one
Oh.
thing. Kranti had some question. I'm sorry, I didn't check the chat. I don't know what time it was. It was a long back. I think he's not there also. I think I can stop the recording. Yeah. I think whenever negative value come, check I and I plus 1 index value. If negative, then go ahead, because I plus 1 is contiguous.
Madhuri can stop the recording. She's the host.
Okay. Is she may be out of the.
Okay.
Oh, you
So
don't. Yeah, word. Komal. Hey, can you hear us? Madhuri, you are the host. Yeah.
Madhuri, what can she hear us?
Yeah, what's that, Komal? You had some
yeah.
questions?
So the difficult problem which we skipped yesterday, are we doing it on Sunday?
Yeah. We
Oh,
will.
okay.
So I'll just pick up all the problems what we have, till now, whatever the difficulties which we couldn't come out and we couldn't understand them very well.
Mm-hmm.
So at least we'll present the way what we thought, okay, and
Mm-hmm.
then someone will help us, to understand them,
Oh, okay.
and we also come
Generally,
prepared for our questions and all that.
oh, okay. So generally same time on Sunday, right?
Sunday it will be like, now it is 8:30. It will be 9. So
Okay.
8:30 PST. So 9 PST. Yeah.
Yes.
So every Sunday also you guys meet?
Yeah, Sunday
Oh,
as well as Saturday also. Saturday same time 9. Then on Saturday we have a system design session.
oh, okay.
Yeah. So
Okay.
that is done by Naga. Yeah.
Okay. Okay.
Yeah. Thank you.
Yeah.
Shashank, so what happened? You were not able to close the.
No, she's the, I mean, host. No, I'm not the host, because I got disconnected in between. That's why.
Yeah, that is true. But if we stop the whole thing, will it not stop the recording?
Yeah, it will stop. Like, we'll have to terminate the meeting.
Yeah, let's terminate that quickly.
Okay then. Thanks. Thank you guys.
Yeah,
Thanks.
bye.
Thank you. Thank you.
Thank you. Thanks so much. Thank you.